Hello, chemistry students. Today we are going to talk about types of reactions. And the first type of reaction we're going to talk about are neutralization reactions, since we've been talking about acids and bases. A neutralization reaction is when an acid reacts with a base to form water. It forms a neutral substance, and we typically think of water as a neutral substance. So acids plus bases, which are opposites of each other, to form something neutral. So an example, HCl, which is our acid, plus NaOH, which is our base, will react to form, and I already know this is a neutralization reaction because we have an acid and a base. So it's going to form water. The water comes from the hydrogen on the acid and the OH on the base. That forms H2O, and what's left over is your other product. What's left over is your metal from your base and your nonmetal from your acid, which is NaCl. Now these always form a water, and a neutralization reaction always forms water and a salt. So let's do an example here. H2SO4 plus KOH. H2SO4 is an acid and our KOH is a base. So I know we're going to form water because it's an acid-base reaction. H2O plus, I know, is a salt. So it's the metal, which is K, SO4. Okay, now this matters because we need to do our crisscross. So our K is in group 1, so it has a +1 charge, and our SO4 has a -2 charge because it is a polyatomic. This 2 is going to go down by the K, and then I'm going to erase my 2. And this 1 goes down by the SO4, but we never put 1s, and I'm going to erase my plus sign. Now we need to balance this, and we always balance our metals first. So our only metal in this reaction is potassium. We have 1 potassium over here on the product side, and we have 2 potassiums on the reactant side. So I need to add another potassium over here, so I'm going to put a 2 in the front. Now we balance our nonmetals, or our polyatomics, and we have an SO4 right here. It stays as an SO4, so I'm going to keep it that way. And we have 1 SO4 on the product side and 1 SO4 on the reactant side, so they're balanced. And now I'm going to balance my hydrogens and oxygens. So let's do hydrogens first. We have 2 hydrogens right here, and we have 2 hydrogens right here. So 2 plus 2 is 4. So we have a total of 4 hydrogens on the reactant side. And we have 2 hydrogens on the product side. So I need to put a 2 in the front to make a total of 4. Now we're going to balance our oxygens. We are not going to take into account the SO4 because we kept it as an SO4 over here. So let's look at these oxygens over here. We have 2 oxygens right here. 2 times 1 is 2. And then we have 2 oxygens right here. 2 times 1 is 2. So we are now balanced. Now let's do this neutralization reaction. We have nitric acid plus aluminum hydroxide. I know this is a neutralization reaction because it's an acid plus a base. And all acids and bases form water, so I'm going to put on the product side H2O plus, and then whatever is left over, my salt, which is my metal, which is aluminum, whatever's left over on an acid, which is NO3. Now I'm going to write my charges. Aluminum is in group 13, so it has a +3 oxidation number. Nitrate, the polyatomic charge for that is a -1. So now I'm going to crisscross. That 1 comes down by the aluminum, and we never put 1s, and I'm going to erase that. This 3 goes down by the nitrate, and since there is more than 1, that means I need to put parentheses around my NO3, and that 3 goes down by the NO3, and I erase my 3 on my aluminum. So now we need to balance this equation. We balance our metals first. We have 1 aluminum on the reactant side and 1 aluminum on the product side. We now do our polyatomics and our nonmetals. So our polyatomic NO3 over here, we have 1 of them. It stays in NO3 over here, and we have 3 of them. So I need to put a 3 in front. And now we're going to do our hydrogens and oxygens. Now remember, we've already accounted for this oxygen in our NO3, so we're not going to account for it again. Let's do our hydrogens first. We have 3 hydrogens here, and we have 3 hydrogens here. So 3 plus 3 is 6, and we have 2 hydrogens here. So I need to put a number in front here to make 6, and that would be a 3, because 3 times 2 is 6. And now I need to account for my oxygens. Now I've already accounted for these oxygens in my nitrate, so I'm not going to account for those again. Over here I have 3 oxygens, and on the product side I've already accounted for these oxygens, so I'm going to look at these, and I have 3 oxygens over here. So we now have a balanced reaction. Now our second set of reactions is our oxidation-reduction reactions. Oxidation is when an element loses an electron, and reduction is when an element gains an electron. Now a good acronym for this that I would like for you to memorize if you have trouble memorizing which one oxidation and reduction is as far as electrons gaining and losing. Oxidation is loss of electron and reduction is gain, and the acronym for that is oil rig. So if you can remember oil rig, and then I believe you can probably just fill in the rest. Oxidation is loss, reduction is gain. So let's look at an example here. We have lithium, and it turns into a lithium ion plus an electron. Lithium is what we started with, and a metal with no charge has an oxidation number of 0. So before it reacted, it had an oxidation number of 0, and then it became positive. So would this be oxidation or reduction? Well, it lost an electron because it went from 0 to positive, which means it became more positive, so it had to lose an electron. So lithium would be oxidized. And a little hint to this, guys, most metals are oxidized. Let's do another example. We have Br2, which is bromine gas. Its oxidation number is 0, plus 2 electrons will give off 2 bromines. So this bromine went from an oxidation state of 0 to a negative, which means it had to gain electrons, and if it gained electrons, that means it was reduced. So bromine was reduced. Redox reactions are also oxidation reactions, also known as oxidation reactions, and they always occur simultaneously, and they tend to form ionic bonds. So now let's look at this. We have 4 irons plus 3 oxygens give off 2 iron oxides. Now we need to find out if this is an oxidation-reduction reaction, and how we do that is to see if the oxidation numbers have changed. Now iron, Fe, it is a metal that is not bonded with anything else, so it automatically has an oxidation number of 0. In oxygen, also, O2 has an oxidation number of 0, all of it together. Now Fe2O3, that's an ionic bond. Fe is a metal, O is a nonmetal, so they have their ionic bonds. So the which means they have to have oxidation numbers. The oxidation number for iron is a +3, and the oxidation number for oxygen is a -2. So iron went from a 0 to a +3, and in order to do that, did it have to gain electrons or lose electrons? Well, it would have to lose electrons to become more positive, so the iron was oxidized. The oxygen went from an oxidation state of 0 to a -2, so it had to gain electrons, become more negative, in order to go from 0 to negative. In order to go from an oxidation state of 0 to -2, which means that oxygen has been reduced because it gained electrons. Now this is what I mean by when I say that they occur simultaneously. That the oxygen will have to gain the electrons that iron is giving up in order to form Fe2O3, by the way, which is rust. So now let's determine which of these elements or compounds has been oxidized and which has been reduced. Now H2 has an oxidation state of 0 and Cl2 has an oxidation state of 0. Now remember, only ionic bonds have charges of plus and minuses. So H2 has 0 and Cl2 has 0. Now let's look at our HCl. This acts like an ionic bond because it is a strong acid. So H has a plus charge and Cl has a minus charge. So we're going from an oxidation state for hydrogen from 0 to plus. And when that happens, it is losing electrons. It has to lose negativity in order to go from 0 to plus. So that is oxidation. Hydrogen has been oxidized because it lost electrons. Now the chlorine is going from 0 to minus. And in order to do that, it has to gain an electron in order to go from a charge of 0 to a -1. And reduction is gain. So here hydrogen has been oxidized and chlorine has been reduced. Now let's do one more example. You pause the video and work this out on your own and then come back and check your answers. All right, sodium went from a 0 to a +1, so it was oxidized, and bromine went from a 0 to a -1, so it was reduced. Remember, most of the time, metals are oxidized and nonmetals are reduced. Thanks for watching.